Hi, this is Tesla Radiant Energy Part 3. It is our small corner for chemistry and electrochemistry. In this video I will talk about the relationship between radiant energy, Tesla's radiant energy, and electrochemistry, like application. So safety first for everybody who has no too much experience with high voltage and with chemistry. I do not recommend to try at home or to try to repeat. In first video I said that I said visible spark and not visible spark. Spark is plasma. What this means that the plasma is all around, no matter do we see the plasma or not. So, if on the end of, let's go to application. On the end of first video I described with carbon rod, electrode and iron or tungsten that it produces DC current, even it is secondary coil of high voltage. In that time it was Tesla coil. I tried to split the water with that way, so I put the iron sharp, actually nail, on the bottom of vessel with water, and it was on high voltage terminal of Tesla coil. The carbon was on the ground, lower voltage terminal, grounded. So it produced the arc, and it started to bombard. So it started to heats up the iron, and iron gets to be red hot. It heats up the water around, so evaporation is bigger. So then after that, and water molecule in the air like vapor are involved in bombarding the iron and the carbon. So we got so much flammable gases and hot water. But because it's carbon, and beside hydrogen and oxygen, there was carbon monoxide and dioxide, and that's why I left this principle. Even it produced very good results. Also we are losing the carbon electrode by the time. On the end of previous video I show splitting water with a gap, where high voltage produce plasma here, and it's split the water or liquid. It doesn't have to be water. Also I said that this it is high frequency, high voltage output, that I had problem to find the electric which will not be burned after a long time of use. There is also a good side of that. If it's the electric organic material, this tube is organic, and this it could be liquid, could be water, or also could be some organic liquid, even oil fuel. But in that case we are make decomposition of organic material, which consists so many hydrogen and oxygen in them structure, and carbon as well. So with a very low current, then on the beginning we are producing very high amount of gases until this surface, where is the gap, because carbon will left, so until this surface is carbonized. When this surface is carbonized, is going to be like this, like carbon, and it starts to produce carbon oxide and carbon monoxide. It is one aspect. Another is it is conductive. It's not dielectric. But this project has some advantages, and let's say for oil fuel, which has to be preheat until it's burned, so it could be good way for make application. So it doesn't. We don't have to split only water. We can also can use waste oil or small or waste plastic to burn. Actually, it is like something like pyrolysis, ignition by high Tesla radiant energy. Because over here, like I described, we have bombarding of ions which are pushed by this energy field. Until I have so if I want to split only water, I have found that I must use anorganic tube or dielectric. So because when I try to get the maximum length of this gap, if it is too high, then I notice that it produce small bubbles jet somewhere, especially if I use porous ceramic. So when the current and the gap was too long, current too slow, it produced some small some path and produce these bubbles which are flammable, which means that it consists hydrogen. Then I start to try to change direction, because I have problem with high frequency, high voltage Tesla radiant energy, because it's burned every material which I tried. Then I made compromise and I go down with frequency. So then I made, let's say, this is power supply, which we can see inside. Because it's capacitor, in the ballast and rectifier. So simple. Or here is a diagram. The capacitor is just in case to make current limitation, because this inductor is 400 watts from sodium lamp. Because this inductor is in DC part, it doesn't have different behavior than in AC. I like to use 70 microfarads capacitor just in case to prevent any damage. So in first video also I said that if you increase some parameter, then other things are involved in process. Over here in electrolysis, if we increase just the current, it will not give some special effect. But if we increase the current density, which means how many amps per square centimeter or square inch we have, so then new phenomenon will come on the surface. Let's say that it is ordinary electrode. It's two electrodes. We have two electrodes, tiny rods, in some dielectric, in some vessel with electrolyte, and when you apply the high voltage will produce high current, but because the surface is too small, we have aggressive bubbling around electrode, both of them. So more and more gas bubbles are gases. Gas is dielectric. So we increase we increase the resistance of this pad on this circuit, and where there is so many bubbles, then we will see the plasma which will form around electrode. It is like it is radiant energy discharge. Because we increase current density, something very strange. Everybody who work with it, let's say we apply between 200 and 300 volts, then we will smell ozone on, let's say it is anode, it is cathode. Actually, cathode. On anode we have to have oxygen. On cathode we have to hydrogen. When you work with that kind of high density current on electrode, on anode we will smell ozone, and it's not all. We will also get hydrogen. It's not so, which means that Faraday law is correct until we are working with, let's say, small amount, with not what I said, when we increase to extreme. So if we have no extreme parameters in electrolyzer, then Faraday law is correct. But when we increase, so new phenomenon comes, so it's easy to check. So we get also hydrogen on the anode, and we have to back to this. In porous ceramic there is tiny tunnels which current pass, so it was, even this current was small, but it was too high current density, and it split the water and produced a very jet of bubbles. I will make some tests to explain it a little better, or to make small demonstration. This plastic tube is drilled with small holes. There are so many smalls like these ones in this plastic tube, and I put one electrode inside, another outside. So we will, which means that between two electrodes, we have barrier with tiny holes. So when we have high voltage, we will have high density current through these holes, which will split water and produce plasma, and both sides of this plastic will produce bubbles, flame, hydrogen and oxygen. Even we put here 220 volts, but when plasma discharge is happening, we have about 900 volts peaks here. So we will have enough voltage to do that. I will just switch off for this test the light. Now I will see the plasma it's creating and produce the bubbles. You need to try alone how many holes to make, and what diameter to make to get the best performance. So because we have vapor chemicals, I will switch off this. When I made in close chamber this test, I got result that I had about 3 times more hydrogen than the current pass, which we can make calculation by Faraday law. So it was also the evidence that these bubbles on the plastic, can you imagine the plastic can split the water? And what is also very important, this plastic do not burn, because this plasma produce jet which repel, and plasma do not touch the plastic wall. Then I change approach again, because I made these holes. Then I got idea why I will not cover anode or cathode with some compound which is high resistive and porous, and it will produce small tunnels where radiant energy appears and discharge through them. We can make on anode or cathode. For anode I use sodium silicate, so which means silicate goes on anode, cover anode with very high conductive layer. But working with silicate is not easy. Then I change chemical. Then I use sodium aluminate. So which means then I'm covering. This chemical is expensive to buy, but you can make alone if you use sodium hydroxide and put aluminium to dissolve, and after that you need to filter it, and you will get a solution of sodium aluminate. When you make high voltage electrolysis of this chemical, sodium will go on cathode, aluminium oxide will cover anode. It is tungsten rod, it is stainless steel cathode. I will again switch off. So which means I will cover with aluminium oxide. Aluminium oxide is very high resistive oxide. So let's try to see what very nice, not aggressive plasma it's producing, and very it is what I'm talking about. It is radiant energy inside of electrolyte. It is let me switch off now. It is with covering anode. We could do the same with covering cathode. For that I'm using ordinary limestone calcium hydroxide. So when electrolysis happens, calcium goes on cathode and cover with calcite cathode, which calcite is also very high resistive compounds, and it will and porous, and it will also produce has so many tunnels, tiny tunnels, where radiant energy will appears. Have a look. So not aggressive, very nice, but it could be aggressive. I'm using for this video or just for presentation. It's not final unit. So now I describe two principles, because the basic problem with working with cold fusion and plasma is to keep electrodes. People who work with cathode plasma, they are losing tungsten very fast. So I just show how to solve this problem using simple chemicals. And what also is very important to say here, the quality of this gas. Now I will go a little to talk. Many of you know about brown gas. That brown gas has different properties than ordinary mixture hydrogen oxygen. There's so many theories about it. Why is brown gas different than ordinary hydrogen oxygen mixture? But ordinary chemistry predict brown gas in some sense. In chemistry is know that depends how you produce hydrogen. Then you have many levels of hydrogen activities. So if there is known if supertension of electrodes. So if it is higher supertension of electrode, which is using for splitting water, is more active hydrogen. And it let's say with if you use stainless steel or nickel electrode, or if you use zinc or lead electrode, it will not be the same activity of hydrogen. Also, which means higher voltage to get hydrogen. This hydrogen is more active in chemical sense, in energy sense. Brown gas you have to produce with pulsating current. So I made test before. It is steady current. It is steady current, let's say, which I'm using for in electrolyzer. But if I'm using pulsating, then the current looks like this. And break. So see that this surface, these peaks are much bigger than steady current. So this amount of current produce hydrogen which is more active than this getting by this current. Also, if you look the line of metals which produce more active hydrogen, you will see that is the same line for between potential metals and for reflection of X-rays. So it gave me idea and answer that producing by this energy, radiant energy peaks, they are actually then it means that this hydrogen when it's produce some kind of X-rays, not in the X-rays like we use to have just small amount, very low level of, but their X or is also radiant energy, like Tesla described how to they are put X-rays in radiant energy basket. So which means that we do not, with using radiant energy for splitting water, we can say, okay, we have some amount of heat and some amount of gas, where is excess. Excess could be in energy stage, or let's say activity of this gas. It is one aspect. Another aspect is transmutation of electrons, which happens. We sent it few years ago few electrodes to Belgrade to get chemical analysis, and they confirmed that transmutation of electrodes happens. Then we sent to Paris another set of electrodes, and we get confirmation from them also that transmutation is happening. So I hope that I gave bigger view of Tesla's radiant energy, where it present around us. Thank you for watching.